presentation on the electromagnetic spectrum. There are many different electromagnetic waves. The type of wave determines what it is used for. Many waves are not visible to the human eye other than visible light, which sits in the middle of the spectrum. Visible light has varying wavelengths to produce an assortment of colours, and this is how we differentiate between blues, reds and greens, etc. There are several types of waves that are listed on this PowerPoint on the next slide. There are several types of wavelengths. The longer, slower wavelengths are used for communication, such as TV and radio. The shorter, higher wavelengths are used for medical equipment, such as X-rays and gamma rays. They have a range of different wavelengths, frequencies and amplitudes. Electromagnetic waves travel through a vacuum at a velocity of 300 billion nanometers per second. The use of the word velocity rather than speed is to describe the movement, as speed would suggest it can be in any direction, but waves travel in a nectar, which means a specific direction. They are colourless, odourless, and they are all around us every day. We cannot see most wavelengths, however we can feel the heat from the infrared wavelengths. Ultraviolet waves can be damaging to our skin, and X-rays and gamma rays can be damaging to our health. Properties of waves. The distance between the peaks is called the wavelength. They are measured in meters. The frequency is the number of peaks per second. So if the wavelength has lots of peaks, then the wave is a shorter, higher wave. This is measured in cycles. One whole wave is a cycle, and the unit it is measured in is called hertz. The amplitude can be known as energy or volume on a radio, and this is measured by the wave peak from the centre line. The higher the peak, the more energy it carries. Infrared wavelengths are not visible to the human eye and are on the spectrum at 700 nanometers. They are 1 millimeter in wavelength. They are used in thermal imaging, helicopter cameras and handheld devices to detect heat from buildings. They are good as they can pass through block light and objects to find sources of heat. However, they cannot pass through glass, as infrared light reflects from the glass and it's unable to pass through. Infrared light helps us measure temperature. The cooler something is, it will show up dark and dark blues, and the hotter it is, it will show up bright red and orange. TV remotes are a small scale infrared wave. By clicking the TV remote, it sends coded signals to the TV to then operate it. If you could see the infrared light working, it would look like flashing Morse code to send the signal to the TV. Microwaves are an oscillation of energy, and these in the electromagnetic field. They are on the spectrum between infrared and radio wavelengths. They travel in straight lines and extend hundreds of miles. They can travel through objects and are used to keep us connected. They travel through a satellite or a Bluetooth system, keeping our mobile phones and electronic devices connected. Microwaves can also be used in ovens to heat up food. They work by vibrating bipolar molecules, which then align, causing localized heat from an object. CT scans and X-rays are a form of ionizing radiation. They work by using a wavelength of ionizing radiation at a dose that is low and safe as possible. These wavelengths bounce off a sensor to capture the image. X-rays can be used for diagnostic techniques in operations, dental procedures, and for comparison if somebody has a degenerative condition. In a medical setting, The dose of radiation is very controlled and given as low as possible to take the image that's needed. However, if you're exposed to a high amount of radiation or a consistent amount over an extended period of time, this can have harmful effects. Radiation can cause the cells or our DNA in our body to die and mutate. Mutated cells and DNA can cause cancerous tumours to form. Protecting ourselves as professionals is particularly important. It's important to stand behind safety lines when taking X-rays, always use correct PPE like lead-lined aprons, and to wear a dose meter to monitor the amount of radiation you are receiving. There are also natural occurring sources of radiation from the earth, like the radiation we get from the sun, and it's also found in some rocks. That's just a diagram to show you how the microwave works to heat up. Visible light is a small band in the electromagnetic spectrum that is visible to the naked eye. Wavelengths of white light refract from prisms of glass or raindrops, making different wavelengths occur. The more wavelengths of colour refract are indigo and violet, that is why these are more potent, you can see them. The longer wavelengths of colour like oranges and red are sometimes not as bright or as visible. They travel between a range of 400 to 700 nanometers and can be measured in terahertz. Red, blues and greens are our primary colours of light. Combining them would make our secondary colours, just like when we mix colours at school in art. Some objects absorb pigment and refract certain colours. Black cannot be refracted from an object, so it's fully absorbed, storing the energy. That is why black clothing or an object radiate heat. That is the energy from the wavelength that has been absorbed. Visible light slows down when penetrating through glass or water. The image through the glass or water can look distorted due to the wavelength, depending on how it went through the atomic mass. As the wavelength leaves the mass, the energy speeds up. Ultraviolet light cannot be seen to the naked eye. It is on the spectrum visible between light and X-rays, and it travels between 4,000 to 10 nanometers. It has a lot more energy than visible light, and it can be harmful and burn you. So this next slide is just a chart detailing the assortment of colours on the visible light spectrum and what length the wavelengths are. Visible light can be used in many ways. It can be used on electronic devices, TV screens, lights to build up clear pictures. It can be used in printing to build up an assortment of colours. A printer works by spraying charged particles on paper so the colour sticks. It's also used in fibre optics for communication and Wi-Fi. Ultraviolet light is used in paints, advertising boards, and this is to attract our attention in darker lights. It's called day glow paint or day glow light. Humans, animals and plants also secrete ultraviolet pigments. This is called biofluorescence. Particularly human bodily fluids or blood has this property. This can be useful in crime scenes when trying to collect DNA or blood splatter samples. The fluid can be seen with a black light illuminating, helping people or the investigator collect the samples and find the evidence. Some biohazards of infrared and ultraviolet lights. Too much exposure to ultraviolet light can cause burns on the skin, just like if you spend too much time in the sun, you'll get sunburn. Ultraviolet light can also cause cellular changes within the body. This can cause the DNA to break down, causing mutations in cells, and this can lead to tumours or even cancer. Exposure to high-powered infrared light can also cause burns, as the energy from the wavelength produces heat. Also, looking directly into infrared light can be harmful and damaging to the eyes and can ultimately lead to blindness. So this is just my reference page, my bibliography, and then my appendix for all the diagrams on my presentation. And thank you for watching and listening.